In junior form, you learn the concept of central tendency, which includes three values called mean, mode, median. Let's take an example for the idea about it. And then, for example, in a math test, so the teacher tells you that the mean of your math test is, let's say, 70. And then now you've got your result is 80. Do you satisfied with it? Probably yes, because you've got a mark higher than the mean. Mean means so in average your class got around 70, and then many of your classmates got mark very close to 70, etc. And then so if you got 80, that means you're higher than the average of your class. Oh, that's pretty good. But if you want to know whether you are in a very high rank in your class, actually central tendency can't tell you about this idea. So that's why in this chapter we introduce another concept called measure of dispersion, which tells you about like highest value, lowest value, and then Q3, Q1. If you still remember, you learned something like this in Form 2 or Form 3. And then for example, if I tell you the highest mark in your class is 95, wow, then you may be a bit unhappy because you've got only 80, which is a mark quite far away from 95. But if I tell you that Q3, which is called upper quartile, and if you forget it, it doesn't matter, we'll revise it very soon. And then Q3 means upper quartile, that means 1/4 of your class got higher than this mark, Q3, for example, 79. Then in this case, you will find that your mark 80 is quite good because you are in the top quarter, top 1/4 in your class. Now let's start with the three common measures of dispersion that you will learn in this chapter. So the first one is called range, and which is talking about the highest value minus the lowest value. While number two, which is a new term called interquartile range, and sometimes in short we'll write IQR in our notes, and which is equal to Q3, the upper quartile, minus Q1, which is the lower quartile. And while for the last one is a very total new thing to you, but it will be very useful in your first study in your tertiary education, which is called standard deviation. And then so we may use the short form SD to stand for it, or sometimes we may use a symbol, a Greek letter sigma, to represent it. So later we'll try to read the idea of this term, these measures, one by one very carefully. So now we start with the easiest one, which is called range first. Range in math is a bit different to our common understanding in our life. For example, the range of an exam, it may be from 0 mark to 100 mark. And then for example, like so in Form 5, most students, your height will be ranging from like 140 cm to, let's say, 180 cm, for example. But in math, we want to, we are not just talking about the range from where to where itself, but we are talking about the difference between them. So that's why the following two, you can say formulas, tells you how we get the range, which is a very simple thing. Range can be largest value minus smallest value, or we can have highest class boundary minus lowest class boundary. Then you may have a lot of question marks in your mind. How come there are two formulas over there? The reason is because sometimes the data is grouped, sometimes it's not. So then you can also highlight the following. We may talking about ungrouped data and grouped data. What does that mean? And then so let's take example 6 as example. Can you see that the example tells you the monthly salaries of two teams in a company, on which you can see the numbers precisely one by one. You know a certain guy gets $7,500 per month, and the other one is $6,340, and so on and so. And then we say this is called ungrouped data. because you can see the data, you can see the values very precisely one by one. When you go to the next page, when we talk about example 7, it is example about the length of babies, and you will see that you also how heavy of a particular baby. What you know from the picture is you know there are two babies. For example, in the first bar, there are two babies ranging from blah blah to blah blah, and then so in which the class mark is 42.5. But for these two babies, are they like 42 kg, 42.5 kg? We don't know. So this is called group data because so the weight of the baby were classified into several groups. So let's see whether you can understand the idea of group data and then group data very quickly in these two examples. Okay, so now let's take a look in example 6. Example 6 is a relatively easy question because it's just talking about range, and then so it's asking you about the range of the salaries of team A, team B respectively. So that's why you need to calculate it one by one. Okay, first of all, for team A, the range will be, so according to the formula, you just seek for the largest value and smallest value, which is $10,000 and then 6050. So this range will be 10,000 minus 6050, which gives you 3950. And then so in statistics, don't forget that in most time we have the unit sign, so which is dollar. While for team B, and then we do the same thing, we search for the highest value and the lowest value. Highest one goes to 9200, while the smallest one goes to 6100. So you have 9200 minus 6100, and then so which gives you the value of $3,100. So after we've got the range, of course we want to do some comparison or maybe analysis in this situation. And then so you see the wording will be which group of data more dispersed. And now you can recall the heading. The heading of our chapter will be called measure of dispersion. Dispersion, it means that is about how spread the data will be. The more spread the data will be, that means they come from two far ends, and we call this is called dispersed. So that's why when the question is asking you about more dispersed, and then you will seek for a higher value. In team A, because you see the range of the salaries of the team is larger, 3950. They come from the highest value $10,000, smallest value $6,050. So that's why in part B, then you would say because 3950 minus 3100 not minus, it should be greater. So the greater the value of the range, it means that the data in team A is more dispersed. So hopefully it will be a very easy task to you by using the range to make a simple analysis. Coming up next, we will see a question on group data. That means the babies, the length of babies here, they are grouped in according to their lengths. So in this kind of question, we need more works because we have some terms that you need to revise earlier. First of all, in each bar, there will be a representative, which is the middle value over there. For example, now in the length of baby, the highest, the last one, you see is 58.5, and then so this is called the class mark. So in each bar, there is a representing value 58.5, 54.5, 50.5, etc. They are called class mark. And the next, this class mark is obtained from the average of two values, which is called the boundary. You see there are two red values here representing the start and the end of each bar. And then so in order to do it, you need some calculation, or you can do mental. For the first one, you will see it's right between 54.5 to 58.5. If you can do mental quickly, you've got the answer 56.5. If you can't do so, then you can take the average. 54.5 plus 58.5 over 2, which gives you 56.5. This value is the start of the last bar, last group, which is called lower class boundary. So accordingly, 56.5 to 58.5, so it carries a difference of 2. So that's why the last one will be 58.5 plus 2, which gives you 60.5. So it will be called the higher class boundary, so of the last group. According to this concept, then you will see in the second last bar, second last group, the class mark is called 54.5, while 56.5 will becomes its higher class boundary, and 52.5 will be the lower class boundary. Next, and then so can you fill in the two numbers in the first group in the lengths of babies in group A by yourselves? Let's take 10 seconds to do so. Alright, okay, so then this one will be 44.5, and so this one will be 40.5. Coming up next, we try to take a look on what exactly the question is asking about. It's called finding the range of the of each group of babies. That means you need to find them one by one. Now we take a look in, okay, well, let's wait. Like group A first. Group A, okay, the range is, so what, the range, what's that? And then so this time, because you don't see individual data, you can't see the smallest value, you can't see the largest value because the data are grouped. So that's why in order to do so, we will seek for the lowest class boundary, which is 40.5 in group A, and then you need to find the highest class boundary, which should be 54.5 plus 2, which gives you 56.5 in order to get the range. So that's why the range this time will be 56.5 minus 40.5, which gives you 16.5 in group A babies. Once again, oh no, sorry, if I make a mistake, should be 16 only. And so once again, in statistics, it's very likely we have units. And now I find that I missed the unit cm. If you remember, I have a little tip for you in exam, which is wherever you see unit in the question, use a highlighter to highlight it. So it always helps me to remember to write the unit in my answer. Okay, afterward we come to group B. Group B, you've also got the ranges 60.5 we've got already, which is the highest class boundary. The other end would be 38.5 minus 2. 36.5 will be our lowest class boundary, and as a result it's 24 cm. Then we complete the two questions very quickly. Finally, we try to see the follow-up question in part B. Normally it's like comparison of the data, and you will see the question is called more uniform length. So this time there is another wording. Uniform means it's called less dispersed, is more close to the mean, etc. So that's why more uniform means that the lower the range is, which is 16 less than 24 in group A, group A carries a smaller range. So that's why we call group A is more uniform. and then we call group A babies have more uniform length. So besides more dispersed, less dispersed, and you can see we can use the word called uniform in the question. After the easiest one called range, now we come to a more difficult one called interquartile range. Interquartile range here. And then so the formula first, and then it's called Q3 minus Q1. So the following table or figure shows you the principle of finding Q3, Q1 in a set of data. And then so you can also highlight some wording, and then Q1 is called lower quartile, Q2 median, Q3 upper quartile. And so these are the three main values you need to remember by yourselves. And then because Q1 talking about the lowest 25%, so that's why we have another word called P25 in junior form. And if you still remember this word P is called percentile. As far as I remember, it's called 25th percentile, maybe. Okay, while median is talking about the middle, that's why we have P50. Q3 is top 25%, or we call P75 here in junior form. Afterward, we come to see how we are going to do Q1, Q3 respectively. It's not really an easy task. Please take a note. Okay, first of all, it's like cutting. And then so take example A, for example. There are 1, 2, 3, 5, 4, 5, 6, 6 data. So that's why in order to cut half and half, then we cut it in the middle. And then in this case, Q2 will be lying between 6 and 8. So that's why it's not precisely a value in the set of data, but we take the average, which is 7. Okay, next, so on the left there are 3 data, so that's why the middle one will be our Q1. While on the right we have 8, 12, 13, the middle one will be Q3. So that's why interquartile range will be 12 minus 5, which is 7. So let's see whether you find it's alright for this question. Okay, after that, let's take a look on B. B will be 1, 2, 3, 4, 5, 6, 7, 7 data. So that's why 9 will be the middle number, and then we call Q2 is 9. Next, you have 3 numbers, 1, 5, 7 on the left, which gives you 5 is the middle one, so that's why Q1 is 5. And then on the right there are 3 data, 14 is the middle one, and then Q3 is called 14. And next interquartile range will be 14 minus 5, which gives you a 9. It's not easy, right? And so that's why you need to read the numbers to the question very carefully. Somehow the most complicated case come from like in part C, because you have 1, 2, 3, 4, 5, 6, 7, 8 data. In order to cut it, you cut it here. So that's why Q2 will be right between 2 and 2. So calculation is not necessary. You can write 2 directly, or you may as stupid as you write 2 plus 2 over 2. But hopefully I don't suggest you to do so. And then while on the left, there are 4 data. So that's why Q1 lies between minus 1 and 0. You can cut here also. Q1 will be minus 1 plus 0 over 2 is minus 0.5. While on the right, you have 2, 4, 6, 7, cut at the middle. So Q3 will be 4 plus 6 over 2, which is a 5. And finally will be interquartile range gives you 5 minus negative 0.5, which is 5.5 in the question. Part D and E, I leave it as your own exercise. Next example 9 is very easy. I leave it for you as well. And then Next, so it comes to a very commonly find question in public exam, which the question is also testing you the concept of a very special kind of diagram called stem and leaf diagram. And then, so let's take a minute to revise it very quickly. Stem and leaf diagram includes stem and leaf here. And then, so what does that mean? That means is 10 cm, that means here 1, 2, it means 120. 1, 3 is 130, etc. So when you read the leaf together, and then you will see that it's 1, 2, and 5. So that's why this value, it means 125 there. Similarly, there are two more data, which means 132 and 137 respectively. So that's the basic principle of stem and leaf diagram. And you will see it carries a very big advantage because it tells you something distribution. For example, when we talk about boys, most of them they are 167, 17 something, 16 something and 17 something in the height, while for girls most of them they are 14 something and 15 something. The second advantage of stem and leaf diagram is kind of grouping, 1, 2 something, 1, 3 something another group, 1, 4 something another group, but at the same time it also tells you the precise value, exact value of every individual boys and girls. So it will be a very good one when you read the data. And then, so in order to, now we come back to the question, it's asking you about number of boys and girls, and so now you will see each number on the leaf means boy. So that's why 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then you know there are 20 boys there. While for girls, you can't see by yourself, can you? Also 20 girls. So counting the number of data in the leaves helps you to know how many boys and girls, how many data over there respectively. But coming up next is hard because it's talking about interquartile range of height of boys and girls respectively. When you go back to example 8, so when you list out all the data, so far you can still find the ways to find the interquartile range. But in stem and leaf diagram, it requires you some more analysis because I don't think you will be so stupid to write 125, 132, 137, etc. Right? So that's why you can pick out a piece of rough worksheets and help to do the following work. So let's start from boys first. Boys, there are 20 boys, so 20 boys here. So in order to find interquartile range, we try to cut it into 4 quarters. So first of all, we cut it in the middle. Can you think of how many boys and on the left and on the right respectively? Yes. So there are 10 boys and 10 boys and 10 boys on each side. And then next you need to cut one more time. And then 10 boys on the left, you cut it half by half. So that's why there are 5 boys and 5 boys. Similarly, on the other side, 5 boys and 5 boys. So where you cut it, so it gives you Q1. Where you cut it, it gives you Q3. Now the problem is Q1, Q3, are they a particular value of a data, or is right between the data? So it requires you to think carefully by yourselves. On Q1, there are 5 boys on the left, 5 boys on the right. So that's why it should be right between the 5th data and the 6th data respectively. So what is it? Then you need to count it one by one. It should be 1, 2, 3, 4, 5, 6. So these are the 5th and the 6th data, which gives you the Q1. On the other side, Q3, there are 5 boys on the right. So you count 20, 19, 18, 17, 16. So it should be the 16th data, and so it's also 50th data respectively. Now you count 20, 19, 18, 17, 16, 15. Then you can find out the Q3 in this way. That's why interquartile range of boys is indeed is not an easy task, because Q3 come from 175 and 176, take the average, while Q1 comes from 164, 159 over 2. Now take out your calculator and you get 14 cm for the answer. Not easy, right? Now can you try to think of girls by yourselves? Because by luck it's also 20 girls. That's why the 5th data, 6th data gives you the Q1, 50th and 16th data gives you the Q3. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16th. So as a result, maybe I don't write the words and just show you the calculation. Girls. And now it's 162, 163 over 2. Q1 is easy because both are 6 and 6, so that's why it's 146. And finally give you 16.5 cm. So that's why in stem and leaf diagram, when you are going to find the interquartile range, it requires you more thinking about the positions of Q1 and Q3. That's why you need to take more effort to do or to understand this part.